Hello and welcome to Autonomie video tutorial. My name is George Burke and I'm a research engineer at Argonne National Laboratory. And in today's video, I'm going to show you how to create a new powertrain architecture or configuration using Autonomie. So for this demonstration, we will be using the 2023 U1 version of Autonomie and 2022B version of MATLAB, but it can be done in any other previous version of Autonomie and MATLAB. So to get started, let's go into the Amber GUI. So here you go. So from the workflow, we'll select edit and run vehicle. You can select any other option as well. And first I would like to show you the vehicle configuration that we will be using for demonstration, and then what modification we'll be doing to it, and we will do some trial run to see how the result changes after we do some modification to the powertrain. So for this demonstration I will be using the hybrid vehicle. So this is the one which I have created for the demonstration. So this is a parallel hybrid vehicle, and this is the powertrain looks like. You have the starter, engine, the mechanical accessory, the torque converter, the gearbox. You have the energy storage and the motor, and the power converter and electrical accessory. So what we are going to do is we'll do some modification to this and see how to do that and how the result changes because of that. So I will select this vehicle. It will take few seconds to load. Alright, so first I would like to show you the default architecture that we have. So you can go to the graphical view and double click here. So in this particular hybrid vehicle, we have uh, the torque delivered from the gearbox and from the motors to the wheels. So what we are trying to do is to add another gearbox or single reduction unit at this point in the space after the motor, and in the demonstration I will show you how that is to be done, and we'll compare the results as well. So for comparing the results, I will just run a simulation with the default vehicle over here so that we have the results in place. So we'll go to select process, then you can select any cycle. I will select the UDDS, and then I will just run the simulation. So uh, by doing this, we will have results from the default vehicle in place, which we can use for later comparison. So I wanted to have it in place once it is done, we can go into the modification part of it. I think it's done. Okay. So here is what you can see, the speed trace. There isn't any speed trace miss for the vehicle during the simulation, and these are some of the parameters from the simulation which we can use for our result comparison, like engine fuel economy and uh, electrical consumption, initial SOC, final SOC. So this is the result for the default vehicle. Now let's go and start modifying the vehicle. So I will go here. So for creating any new architecture, you need to go to the vehicle propulsion architecture and right click on it. You will see here two options: build VPA configuration model with annotation, and import and use configuration from annotated model. So if you already have the annotated model, you can select the second option, but in this place we don't have any annotated model, so we'll first go and create one. So we'll select this option, and it is going to open the configuration file over here. Okay, double click. So this is the architecture of the default vehicle where we have all the powertrain component, and what we want to do is to add one torque coupling or single reduction gearbox over here. So let's start making those modification. First I will make some room over here for adding a new block, and so I will move some of the blocks here so that it will look little neat and easy to follow. Okay, great. So we will be adding a block here. So I will delete this signal and copy this motor block and just drop it here. And I'm going to rename it to, to TC, and that is what the name will be giving to this block, and adding the effort from this motor to this component and effort from torque converter over here, so that it get combined with that of the effort coming from the gearbox and goes to the vehicle dynamic block. And now you can see here there are other points which are not connected to anywhere, so we need to make sure it is all the signals are connected. So we will copy main info bus and vehicle dynamics block and connect it to this port over here, and similarly from the vehicle dynamics to this block. So you can take reference of other blocks, how they are connected and renamed, so that you can also connect the blocks in a similar fashion. So this go to block we will name as TC, apply, and main info bus is it's good. We don't need to change anything. You will see error over here because we don't have from block for this, so we'll add it later. And then uh, in the default configuration, um, uh, the signal from the vehicle dynamic block was coming out and going to the motor over here, the way you can see it over here from the vehicle dynamics. And over here this is also a vehicle dynamics block. If I can pull it, yep. But now since this is the last element, so we will move this from block, oops, to this position, and we will connect this port to this port. So we have added a new component over here, TC, torque converter, sorry, torque coupling, and we added one new go-to block, but we need to make sure that it get connected to the main bus. So we will go here to the main bus and double click it. So we need to add a from block for the TC over here. So by default there are 10 inputs. We'll make one additional input to it, apply, and OK. So you see one additional input over here. We'll just copy this one, name it to TC, and apply, OK, and we'll connect this to the bus. And I hope the error sign is gone. Okay, so now we have fixed the error. And when you are doing it for your project, maybe you want to position this properly so that it will look neat, but I will not spend time on that, and save it with a different name the way it is. But you might want to reposition it to make it look more clean. You can do that. So I will go to save as and give a new name to this Simulink file. I will rename it as demo2 and then save it. So once this VPA file is saved, I think we can close it. And again, then you need to go to the vehicle propulsion architecture configuration and then right click. So in the previous step, we have created the annotated configuration model with annotation. Now we need to import that. So we'll just go to select the second option. Uh, we need to see, we need to select the annotated model file. So in the first option, we'll click here. We'll select the new file that we have created. And once you select that, it will populate other information or other files related with that automatically. Sometimes it doesn't happen, so I would recommend you to try it again. But most of the time you will get all the other things getting populated on its own. We might want to write some description over here, so write cloned from VPA, the default file name for adding a torque coupling. I think this is fine. And demo 2, just so that we can later identify which model it is. And you need to click the import button, and hopefully it will import the file. Alright, so you can see here the image over here is changed, and now we can see a DC over here, though it is showing like a motor, but it's basically a DC, and you don't have any, or you have some error message. And the error message is there because in the powertrain architecture we have added a torque coupling, but we haven't added the respective configuration model initialization file and the pre-processing and post-processing file. So in the next step we will be adding all those things. So we click here on the configuration file and it opens a new window, configuration browser. So for selecting this, the options which are showing here could be different for different type of powertrain component, and you need to choose the appropriate one based upon the type of component. So in our case now we are looking at the torque coupling, which is just a plant model and doesn't have any controller in it because it's a single reduction gearbox. So that's why we will not select the first option but select the other option, which is plant, one effort in and one effort out. And if you have other components which does have controllers like a battery, energy storage system, or engine, which comes with a controller, then you need to be selecting the first one. But in our case, since it's a torque converter, we'll select the plant, then click OK. Okay, so we have selected the configuration file over here. Now we need to select the model, and for model we will just right click over, left click over here, and showing the files which we can choose. So we'll choose this file over here. Okay, and then let's go to initialization. For initialization we'll select this one, DC plant 1 with a single gear ratio of 1. So I think that is more suited for our exercise now. Alright, and then we want to select the post-processing file. Okay, for now we are leaving the scaling part of it, but these are the main files that we need to select, and still it is showing some error. Okay, so Let's see. I will just save the vehicle configuration that we have made. Yep. And let's see if if the errors are gone. I think we have one error, but let's try to see whether it works or not. So I will, before going running simulation, I just wanted to show you what is the ratio of the gearbox. So we'll select TC. It's not showing. Maybe select the overwritable. TC planned init mass ratio. So let's see what's the value it is having. So we are trying to check what is the ratio of the torque converter. So if it is 1, then there shouldn't be any changes in the output uh, that we will see. And when we try to compare it with our previous simulation where there was no gearbox, so as you can see here that the gear ratio is 1, so it's like nothing in place over there, so it shouldn't uh, have any effect on the results. So let's try to see what the results look like. It shouldn't take much time. All right. So you can see here, like with the modified architecture, also we are able to run the simulation. But when you see the results over here and try to compare with the previous one, so one FUDS1 is the one without the torque coupling, and 2 FUDS is the one with the added torque coupling. But the ratio that we have added is 1, the gear ratio. So the motor has to do the so basically it is not having impact on the powertrain because the motor has to operate at the same RPM and same torque level. So when you see the uh, fuel economy, it's not going to change because the ratio is 1. And also you can see other parameters like the electrical consumption is 24.5 for both the case. Nothing changed. The final SOC is also not changed much because it is not having any impact on the driving behavior of the motor. But let's try to change that value to some other value. So we'll go to tc.plant.init. So this time we will put a ratio of maybe 2.5, and let's try to see what impact it can have on the simulation results. So you can see here how quickly we can run simulations in Autonomie. Within less than a minute you can get the results. All right, so now we are looking at the results from the third simulation run where we have changed the ratio to 2.5, and in this case also we see that the vehicle is able to run as per the input speed trace, that is the UDDS. But I'm expecting to see some difference in the values, because we have used a gearbox with a speed ratio of 2.5. So let's see whether it affects the fuel economy. So when we see the engine fuel economy, it's 63.1. No, I'm surprised it's not changed. And the initial and final SOC. Okay, we see some changes here on the electrical consumption, which is earlier it was 24.5 watt hour per mile, but now it is reduced to 22.5 watt hour per mile. So it has now you need less energy for covering the same distance, and the effect of that you can see on the SOC of the battery, like you haven't drained much the battery for covering the same distance. So it does have, so it looks like the engine fuel economy haven't changed much, but by changing the gear ratio, you you are able to save some energy, because your watt hour per mile requirement has decreased and your delta SOC has reduced. And in the same way, there will be many other parameters in it which would have been changed because of adding a gearbox over there. Maybe I can show you the motor torque. So if you see the motor torque out in this case, so we can zoom in any specific section over here. So you can see here that the motor torque, output torque, is reduced when we used a gearbox in between with a ratio of 2.5. That makes sense. And similarly, you can see the current speed and the current variation in the motor. So the speed is also reduced for the motor, obviously, because you have a gearbox in between. Pardon me, the speed has increased because you have a gearbox in between, and the what effect it has on the motor plant voltage, that also you can see. So this was a quick demo on how you can modify the existing powertrain in Autonomie using the configuration annotated model option. And you can see here we have added, so okay, it has changed. So you can see here earlier this torque coupling was not there, but it has been updated now. And I think the error will simply go away if we just remove we reload the vehicle again. So nothing to bother about the error message here. But this was a quick demo on how to make modification to different type of powertrain architecture in Autonomie. And I hope this video will be helpful for you. And if you have any questions, you can just drop it in the comment. And thanks for tuning in. And I will see you in another video. Yeah, take care. Bye bye.